Hi everyone, this is Aditya sir, and welcome to this class for JEE students. And today we'll be talking about one of the most interesting thing, that's called gravitation. So first of all, what is gravitation here? Now gravitation is basically a force, or gravitation is basically a force which actually attracts or objects towards a planet. So a gravitational force actually comes with the planet, and it is because of the core of the earth is actually a molten metal, which is revolving, and because this molten metal is actually revolving, there is a force which is generated outside the earth here. So what do we have? Because of this, every celestial object is actually attracted. So every object is actually attracted towards the earth's surface, and then we will see that there is a limit to which point this gravitation actually act. The first person to actually talk about gravitation was Newton, Sir Isaac Newton. He was the first person who came up with an idea is how this gravitation actually works, and how can we calculate the force which is with which any object is actually attracted towards the surface of earth. So this class is going to be very interesting. Let's see. So Newton's law of gravitation, the first and most important thing that we should know is what this law, which is known as Newton's law of gravitation. What does this law do? Actually, every object, actually, if you see and if we go through all the books and materials or internet, you will find out that every object on this earth surface on the planet attracts every other object. Okay, but we don't know. So for example, let's say we have this particular box and another box. There are two boxes, so this box is 1, this box is 2. Now we know that this box is actually attracting and towards itself, and this box is also attracting. So there is a force of attraction through this line of action, which actually attracts all these two, but we don't know with how much strength, with how much force these two bodies are actually pulling each other towards itself. So in order to calculate this, Newton actually gives a law. So this law is known as universal law. As you can see here, this law is also called as universal law of gravitation, because this is true for every two objects or every planet and every other planet or celestial objects in the neighborhood of it. Okay, why neighborhood? That we will talk about it in the coming part. So this force, the formula which Newton's law of gravitation gives is F is equals to G m1 into m2 divided by r square. Means what here? This gravitational force actually depends on the product of mass of the two objects. If the mass of the let's say first mass is earth and second is moon, so earth is actually attracted towards moon and moon is also attracted towards earth. This we can see in the form of tides in the oceans. If you go, the level of water actually increases at high tide and level of water decreases at low tides. And if you throw a ball in the air, you will see that the ball will come back, or it will return back to the surface of earth. Why? Because the earth is actually attracting every object. Earth doesn't want objects which are on the surface of earth to leave the earth surface, right? But any object which is in the neighborhood, okay, not exactly you can say far objects are not getting attracted by the earth, but the planets or the objects which are in the neighborhood of earth, only they can get attracted. After a certain distance, we will see this force doesn't work. So the formula actually was given by Newton, which says that it depends on mass of the two objects. Okay, so if the first object is 1 kg, the second object is 2 kg in mass. For example, this is, let's say the earth is 1 kg in mass and the moon is 2 kg of mass, then and also it depends on distance. So that means closer the objects, as you can see, it is inversely proportional. So force is inversely proportional to square of the distance. That means that if the distance actually increases, if the distance between the two objects increases, if you increase the distance by 2, it will double it, it will square it and make it 4 times. if we increase the distance by 6 kilometers, let's say, it will double it and it will become, sorry, square it and it will become 36 times. So as the distance we keep on increasing, this force actually decreases. The force will keep on decreasing, and the force of attraction. Okay, one more important thing is that gravity is always a force of attraction. It is only a force of attraction. There is no repulsion in gravitational force like we see in magnets or in electrical charges. Electrical charges, they have force of attraction and repulsion, and magnets, they also have forces of attraction and repulsion. But here, in the case of gravitational force or gravity, there is only force of attraction. So as we move these two objects farther away from each other, as the distance, so the distance will increase, the distance increases, the force decreases. But you can see here, both the force is directly proportional to mass of the two objects. So we have here m1 and we do also have m2. So if the mass of these objects increases, okay, and if we keep this distance same, let's say the distance is r, if we make the mass as 20 kg or maybe 200 kg or 20,000 kg, then the force is going to increase for the same distance. So this formula is very, very important, which helps us in projection of a satellite, in a launching of a rocket or robots to other planets, and also in order to maintain the gravitational force or atmosphere around the surface of the earth here. Okay, so this G is called universal constant of gravitation. The value of G is equals to close to 6.673, right, very sorry, so 6.673 into 10 to power minus of 11, 10 to power minus 11 Newton meter square and per kg square. So this is the force. This unit we can get it from here. If F is equals to G m1 into m2 by r square, we can calculate the unit as well as dimension formula for this universal constant of gravitation. There is an experimental method by which the value of G has been obtained or calculated by the Newton. So here we have the first formula, in the first in the of its kind formula, which helps us calculate the force with which two objects are pulling each other, because it is force of attraction. Okay, so after this, then we need to understand what is weight of an object. Weight of an object which is standing on the surface of earth, weight is nothing but a force. Okay, so we know that from Newton's law of gravitation, or Newton's second law of Newton's second law of motion, we know that force equal to mass into acceleration. If the mass of the object is constant and it is not changing, then only this formula is applicable. Remember that, number one. So force equal to mass into acceleration. And what is weight? If the object is standing here, then the earth is pulling the object towards itself with certain force. Okay, this force is actually known as weight, because we know that force is equals to mass into acceleration. This acceleration is depends on how the object and which forces we are talking about. Here we are talking about gravitational force, which always tries to pull objects in the downward direction. So therefore we have force equal to weight of the object, because mass is equals to from second law of Newton's second law, force equal to mass into acceleration, and weight is equals to nothing but mass into acceleration due to gravity. So this is the value of acceleration. What do we mean by acceleration? Acceleration means, we will see in the coming object. For example, let's say here the mass of the object is 50 kg, and let's say the weight of the object here on the surface of earth is 50 Newton, because weight is always measured in Newton, and the formula for weight is nothing but m into g. So obviously the value of g has to make difference. It makes difference from here. For example, let's say if it goes to Mars, then the value of acceleration due to gravity, this g, the value of gravity, or you can say acceleration, because of the gravity keeps on changing on every planet. On moon it is 1/6. So right now, yes, if we go to Mars, let's say the Mars has a different value of gravitation. The value of, if the value of g is less, the weight will decrease. Let's say it becomes 40 Newton. So here the weight is actually changing because of gravitational effect, but the mass, as we can see from the figure, it is always the same. So every object has same mass if we go from one planet to another planet, but the weight actually keeps on changing. So this is one of the most interesting thing. If we jump from Mars to some other planet, your weight will be different. If you take a weighing meter and if we keep on jumping from one planet to another planet, our weight will keep on changing, but the mass over here, it remains constant, it remains unchanged. Okay, that is one of the most interesting thing. So here weight is nothing but a force, it is also a force, because it is because of gravitation. Here the value of acceleration is given by g, but the value of g actually keeps on changing everywhere on the surface of earth. On the equator it is different, and at the poles, north pole and south pole, the values are very different. So the scientists all over the world, they made calculations at every spot and they averaged it, and they came up with a value of acceleration due to gravity to be 9.81 meter per second square. Okay, so that means any object, if we put it here, if we put any object here, that object will get accelerated. Okay, accelerated means the velocity will keep on increasing at this pace, 9.81 meter per second. Acceleration is nothing but rate of change of velocity, or first order derivative of velocity. Okay, this is what is acceleration A. So we can see here the change in velocity will happen with respect to time. Also we can see the distance. So if the object is left here, it will keep on accelerating up to a certain distance, its velocity will keep on increasing. So that we will see in the coming slide. So this is velocity 1 and this is velocity 2, but only up to a certain distance. After it reaches a critical value, okay, that's called Stokes, that is obtained from Stokes theorem. If we end up getting a critical value, after that the velocity will not change. Okay, so this is again one of the interesting thing. The objects will and if there is no surface, if we are throwing this ball in the air, or if we dropping this ball in the air, then it's called a free fall. Okay, there is no object to act. Here you can see if the boy is standing on the surface of earth, and from the Newton's third law, to every action there is equal and opposite reaction. So weight will be acting in downward direction, and if the surface of earth is actually solid, it will put a reaction force of equal strength. So this is called normal reaction, which we will see in the okay. Then again, checking the acceleration due to gravity, like I said, if the apple is falling from a tree, let's say this apple has been somehow it has been plucked, or maybe it has been tweaked from the surface of, or from the branch of a tree, it will keep on falling, and the velocity of this apple will keep on increasing. Okay, why? Because it is getting accelerated, the velocity is actually increasing, and it is getting pulled by the earth. So closer to the earth, faster will be the velocity. Here the velocity will be different, less velocity. Here the velocity is going to increase, then there will be increase in velocity at third point, and there will be increase in velocity also at the fourth point, and it will keep on increasing until a point where a certain maximum value of velocity is reached, which we call critical velocity, and then it won't change. So here you can see here what is happening here. The boy is on the top of the hill, it is near the cliff of this particular hill or mountain, and then he is dropping a ball here. Here the velocity was 0 meter per second, because the acceleration value, like I told everyone all around the world, we are using it as 9.81 meter per second per second. So the velocity is going to increase at a pace of 9.8 meter per second every second, right? This is how it is actually interpreted. Every second the velocity of this apple is going to change, or the ball is going to change with the value of 9.8 meter per second. This is the velocity per second. That means every second this much increase of velocity is going to take place, and then we can calculate distance using this formula. V is equal to v square is equal to u square and plus 2 times of a into s. This is the formula. So initially you can see the velocity was 0. In 1 second it has increased up to 9.8 meter per second, which is equal to acceleration due to gravity, and in the next second it will double, triple, and again quadruple, and then it will become 5 times and keep on increasing until a certain maximum value of velocity is reached. So this is how the acceleration due to gravity is actually, or gravitational force is pulling the object towards the center of the earth, right? Interesting. Then let's talk about what is gravitational field. So this is interesting to see that these are the formula which using which we can calculate what is the value of g at the center of the earth at depth d, and then or maybe this is d depth is, if depth is equal to radius, what happens, and if we keep on moving away from the surface of earth up to a certain point where g will be there, and the value of g here will be approximately or close to 0 meter per second. So that means up to this distance earth is going to attract everything which comes nearby, and it's a 3-dimensional thing. Okay, it's all the 3 dimension like a football. It covers all the 3 sides, and then beyond this distance it is not going to attract anything. So this region, like for example, let's say if you have a magnet, this magnet can going to attract objects very up to a certain distance. This is called magnetic field. Okay, because a magnet has a certain, depending upon strength of the magnet, the value of this field or the distance up to which the magnet can attract will keep on changing. So this region over here is called magnetic field. Likewise, distance up to which the earth can attract objects, that's called a gravitational field. If something moves, if you throw a ball outside this region, if the ball is over here, it will not attract. Fine. That is one of the interesting things. And then looking for how this value of g varies, you can come up to these formulas. So this is one formula which talks about height and the radius of the earth. Okay, if the height is equal to radius of the earth, here we will take it as depth, you can see here. So if the depth is equal to radius of the earth, g is equal to g naught. Okay, if the h is equal to r, this whole thing becomes 1 minus 1, 0. So that means at the center of the earth, if we keep on drilling a hole, if we keep on making a hole up to a certain distance, at this point edge, exactly at the center where the temperature is around 3000 to 5000 degrees Celsius, where we cannot even stand. Okay, so at the center of the earth, the acceleration due to gravity is 0. As we keep on coming close to the surface of the earth, on the surface of earth, like we have understood, we use the value of 9.81, which has been calibrated by many scientific experiments. So 9.81 meter per second square. This is how it varies on the surface of earth. And as we move away, other surface, if we keep on moving away from the surface, the value of v keeps on decreasing, and up to a certain point it becomes close to 0, like I told you. So this outer edge, invisible surface, invisible region within which earth can attract objects, that's called gravitational field again. So the field has to do with the concept of magnetic field, like I told you. You can also take an example of an electric charge. So every electric charge can attract other objects or other charges, opposite charges. For example, a negative charge only up to a certain distance. Okay, if the charge is placed, if the negative charge is placed outside this region, then it will attract. So this region within which the charges are getting attracted, because this is positive charge, this is force of attraction. Okay, this is how we can present it. Some negative charge kind of a thing. Okay, so if the object is placed outside, and this distance up to which this electric charge, which is positive in nature, can attract object, is called electric field. So we have electric field, we do also have magnetic field, and here we understood the concept of gravitational field. Then coming to the concept after gravitational field, we know that up to a certain distance only the earth can attract. Okay, but if we want to project objects, if we want to throw something outside the earth, what should we do? if we want to throw anything outside the earth gravitational fold, we have to throw, for example, a rocket with certain velocity, which is called escape velocity. The velocity with which the object can escape or move out of the gravitational field. If we want to throw the satellite, or for example, let's say nowadays we are going to Mars mission. Okay, so if we want this rocket to reach to the Mars, we have to throw the satellite with escape velocity, and once it is escaped, okay, it will keep on moving with the same speed. There is, depending upon whether we have more fuel in the rocket. If we burn it, then the speed will increase according to Newton's first law of motion. If something is moving, then it will continue to move, and if it is at rest, it will continue to be at rest. So if we drop a pen outside this gravitational field, it will stay steady. Even if we go 10 years from now, we will be able to find this pen over here. But if the rocket escapes the Earth's gravitational field and it is burning some fuel, or it has some momentum, it will continue to move with the same speed. If we want to increase the speed, then we have to burn the fuel. But the most interesting thing, that if we want to launch this, put this rocket into the Mars orbit, then we have to use certain gravitational forces, and then we have to escape it so that it goes into the gravitational field of the Mars, and then it comes down, slowly settle down on the Mars. So this is our Mars. This is what Indian scientists have used very successfully, and they have been actually looking for, they have done with moon, and they are trying for, we have also solar mission, and we do also have Mars mission. The formula to calculate here is 2 into gm, mass of the planet and radius of the planet, and g is the constant of gravitation. Here from the Earth's surface it comes around 11.2 kilometers per second. So if we launch a satellite or a rocket with this 11.2 kilometer per second, at this pace it is going to escape. Now why this 11.2 kilometer per second? That is also interesting thing. But let's say if we throw a ball outside the above the surface of the Earth, what happens? The gravitational force will start pulling. So if you throw a ball with 10 meter per second up to a certain distance, the speed will decrease because of the gravitational pull, and it will become 8, and then again further up to certain distance it is going to decrease, and it will become, let's say, 4, and ultimately it comes to value 0, and then it will bounce back to the surface of the Earth. That's all for today.